For the past 3 weeks, every clear night, Bob Stevens has pointed his home telescope at the same two stars, hoping to witness one of the universe's most violent events, a nova explosion, which can be 100,000 times brighter than the sun. Scientists have said this explosion could happen at any moment, drawing the attention of major observatories worldwide and promising to advance our understanding of turbulent binary star systems. However, despite the high-tech observation power NASA and other scientific institutions can gather, astrophysicists rely on countless amateur astronomers like Stevens to make the initial detection of the explosion. The reason? It's too costly to focus their equipment on the same target for months. I think everyone will look at it while it happens, but just sitting and watching won't make it happen, said Tom Meneghini, Director of Telescope Operations and retired Executive Director at Ment Wilson Observatory. It's like watching a pot boil, he joked. The star is so far away that its light takes 3,000 years to reach Earth, meaning the explosion happened before the last of the Egyptian pyramids were built. It will only appear as bright as the North Star for a few days before fading into darkness. Once detected, some of the most advanced observatories on Earth and in space, including NASA's James Webb Space Telescope, will join in the observation. T. Coronii Borealis, also known as Blaze Star, is actually a binary star system composed of a hot, dense white dwarf and a cooler red giant. The dwarf star, long since exhausted of its fuel and collapsed to about the size of Earth, has been siphoning hydrogen gas from its larger companion for roughly a human lifetime. This stolen gas has accumulated in a disk around the dwarf, resembling a hot, disordered version of Saturn's rings. Soon the disk will become so heavy that it will violently erupt like a thermonuclear bomb. However, no star will be lost, and the process repeats approximately every 80 years. Major observatories cannot sustain such continuous monitoring. Hundreds of scientists vie every night for time to look at a wide range of astronomical targets. For them, sticking the telescopes to Blaze Star would waste valuable observation time. Predictions for when the nova will occur vary, but most astrophysicists agree it will happen before the end of the year, possibly by the end of August. Several alert systems have been set up to notify amateurs and professionals when the explosion occurs. Stevens mentioned that some observatories have programmed their telescopes to automatically cancel current observation plans and point to the star upon receiving a notification. Major observatories face another complication. Most of their telescopes are designed to observe the faintest and most distant targets, but Blaze Star's nova will be far from faint. Pointing these telescopes at the nova would overwhelm the sensors, resulting in dim, overexposed images. Thus, Palomar Observatory, Caltech's research station in northern San Diego County, is not using its iconic 16-foot Hale telescope under the massive white dome. Instead, it uses a much smaller telescope called Gattini IR, located in an unsuspecting small brick building about a quarter-mile down the road. When the nova occurs, Gattini IR will switch from observing Blaze Star every few nights to observing it every few hours. Some researchers suspect that novae like Blaze Star could be precursors to supernovae, which are explosions billions of times brighter than the sun, destroying the star and often leaving behind a black hole. Supernovae are also useful tools for astronomers to measure distances. However, studying similar events has already led to discoveries. Recently, scientists have determined that novae tend to eject material into space faster than predicted based on the intensity of the explosion. Part of this understanding is due to amateur astronomers. And amateurs can achieve better coverage than large telescopes because, as Sims noted, we often have full control over when and where we can point our telescopes. A professional might have to write a grant to spend half an hour or 2 hours on a big telescope. This allows them to collect a lot of data. And since hundreds of people in the community observe from around the world, Blaze Star can achieve nearly continuous coverage. Many, including Sims and Stevens, submit their data to the American ASAN, a variable star observers website, allowing everyone to use it. Today, the work of amateur astronomers has become so sophisticated that many in the field struggle to call them amateurs.